this footage is not super stripey or anything, but yes, hello, welcome back to the But It's Not That Serious podcast. We are joined here again on my couch at 11 p.m. on a random Monday. It is the week of Thanksgiving, so I'm very excited for a short work week. But today I am going to talk about exactly that. I'm going to talk about work here. And if you guys don't know who I am Michelle Kim. I am 24 years old, soon to be 25. I know, so scary. I'm going to be in my mid-20s. Actually, one may argue that I'm already in my mid-20s, but that said, I graduated from UCLA with a mechanical engineering degree. I worked at SpaceX for 2 years. I also did 2 internships with the same team while I was in college. And right now I work in a defense startup, and it's been about 3-ish months. So that is kind of my work history. It's not very long, but I think today what I'm going to be talking about, so yes, I do have my iPad here because I needed to do some pre-planning, but I wanted to kind of go over what I do as far as engineering and as far as this industry goes, because I think some of my friends have asked me like what exactly I do, and I will try my best to explain it today. But it is very possible that even if I do explain it today, that it's just going to fly over a lot of people's heads. But the engineering episode with my friend last time had like 300 something views. Like, who even is watching this? I don't know. But I suppose that there are some straggler engineering students out there that are actually very curious about what engineering jobs are out there. So both of my work experience, or all of my work experience, I might say, has been specifically in a production type environment. So at SpaceX, I worked at Starlink user terminal. So let's get that right. Starlink is 2 different things. Well, it's one system. There's like 3 different products, like main products that come out of Starlink. It is the satellites. There's the gateways that talk to the satellite. There is the user terminal, which, if you guys don't know exactly what that is, think of a satellite dish that people kind of just mount onto their roofs. It is literally the same thing. We make the same thing. And I will talk about Starlink and SpaceX as if I still work there, because it's just a habit of mine that I don't think I'll ever break. But yeah, I worked on the user terminals. So in a way, I do like to say that I worked on a consumer product, because we got to interact directly with consumers, and we got to see exactly what they thought about it, and got to see field returns, things like that. So yeah, I worked on a consumer product production environment, and specifically high volume production environment. And currently at my new defense startup, we do technically also make consumer goods, except that the consumer is the military. And we'll just leave it at that. But I did want to talk about the different types of engineering that exist in a production environment. And then I personally am a reliability engineer, and I think reliability engineering is definitely one of those niche engineering jobs that most people do not know exist until they kind of enter an engineering field. So it's like definitely one of the engineering fields that you learn on the job, of course, with the help of your engineering background. But yeah, I'm just going to talk about what exactly reliability engineering is, and like kind of what I do on a daily basis, because personally I think it is a very stressful job, but I find it to be kind of fun. I have one other friend that used to be in reliability engineering and then moved to test recently. Actually, Alyssa, the one from the previous episode. She used to be in reliability engineering, really hated it, and then went to test engineering, which is a pretty straightforward path, in my opinion. But I'm just going to talk about like pros and cons of reliability engineering as well, because that's like the engineering type that I know most about, obviously, because it's the entirety of my work history. So I can't necessarily talk about the other engineering types just as much, but I'll try my best. So let's start with, I'm leaning. This is rude. I should be standing a little straighter. Also, it's getting hot because I closed the window. But anyway, I am just going to go over very, very briefly the kind of org structure of an engineering-based company. I will say, I think I can only speak about engineering-based companies, but I do believe that it doesn't matter what industry you're in, the org structure is going to be the same. But as someone that went from student to work, if you're a student and you've never worked in a big industry / company, you don't really know what org structure is until you work in a company. So I'm just going to go over that. It applies to literally every single job. But there is the CEO, or any like COOs. So there's like the people that own the company. And then below them will be the VPs. So kind of like their direct people. And usually there's like one VP per major sector of the company. So like there will be VP of mechanical engineering. There will be VP of supply chain. Like it's very like broad topics that will have VPs. Below VPs, there will be directors or executive directors, and those are, honestly, it's just a bunch of middle management from here on out. Below directors will be managers. So they are more closer to, like, this is when you start getting pretty close to the individual contributors or the ICs. But there's also like another middle management kind of level below that. So it's managers, and then there's leads, which usually leads are both managers and individual contributors. Oftentimes leads will have a pretty difficult time at work because they have to do their own work, but they also have to take care of their juniors. So there's leads, and then you've got the individual contributors, which can be broken down into different levels depending on like promotions or things like that. So usually, actually, I don't know about usually, but at SpaceX there will be E1s, E2s, and then senior engineers. Individual contributors typically are technical by nature, and they are expected to do technical work only and do not have any reports unless they have like an intern that they are looking to nurture. I don't know. But that's kind of like the org structure. Very, very basic. There's usually tons of other weird titles in between, but that's kind of generally how it goes. Now I'm going to start talking about the production engineering structure. So I kind of broke it down into 3 different types of engineer groups. So for any product, program, etc., business line, that's like a new term that I learned recently. There will be the designers, or what I like to call the responsible engineers. I know that responsible engineers, or REs as they call it, is definitely a term used at SpaceX, because they have a very strong culture of extreme ownership. And so responsible engineers typically are expected to own every single thing about their product. So like if it's not reliable enough, it's not really the reliability engineer's fault, it's their fault because they're the responsible engineer of the product. So that's kind of like typically how it goes. But in general, even if they are not titled responsible engineers or do not have the expectation to own every single thing about their product, the designer will know the product and the piece part or whatever they design best. And so they are typically looked for whenever there's failures, whenever there's questions, whenever there's any changes to be made. It's going to be the designer that makes those calls. And within the designers and the REs, the following engineers lie in this category, and typically it's going to be the engineers that you learn about and the principles that you learn about in school. So whenever you go to your design classes, CAD classes, whatnot, you're going to learn skills and you're going to learn the principles of these types of engineering. So it's going to be mechanical design. Typically, in college, I went to UCLA again. You learn about like statics, you learn about thermodynamics, you learn about aerodynamics, and everything is kind of based on how you are going to design and optimize for a certain situation. So that's kind of like mechanical design engineers. And yes, their principles do have to be very strong. They have to know about material properties. They have to know about manufacturing processes and know like the pros and cons of each, know, basic, like if I'm going to make this part, how exactly am I going to do it? Like DFM, that's going to be a term that comes up a lot in a production environment. DFM is design for manufacturing, which maybe I'll go into a little bit. But basically, design for manufacturing, you can kind of put it this way. It's like if you are making say you are injection molding something, which is literally just think of piping hot plastic into a mold and making that into something. If there's going to be really intricate details, maybe that's not going to work out because the injection molding points are not going to be able to reach that area. That's like a very, very broad example, but when you really, really get into the nitty-gritty of design for manufacturing, it gets pretty complex, and it's actually very, very cool. And it's one of the like key things that I was really interested in at SpaceX. But yeah, so mechanical designers, they think about DFM. They again make changes to their design. They make the original design, so on and so forth. Then you got the EEs, so the electrical engineers. So if mechanical designers are going to make the mechanical parts, such as the body of the robot, the plastic parts here and there, the little hinges, fasteners, joints, things like that, the EEs will make the electrical circuit board that will house kind of like the brains of it working. So usually they are the designers of wiring. I think I've seen some mechanical designers do wiring, but typically the electrical engineers will also do the wiring for a system. But the main part that they're going to work on is the PCBA. So what is a PCBA? It is a printed circuit board assembly. Yes, PCBA. If you've ever opened up any kind of electronic thing, like your Switch or your laptop or your phone even, there's that really kind of fancy looking, typically green, board that has a bunch of like square chips on it. And the designers of those are typically the electrical engineers. So electrical engineering to me is black magic, as is RF, radio frequency things. They speak of it as if it is super easy. They're like, oh, just think of it like water. Makes no sense. But the electrical engineers are typically very, very, very smart people. Not saying that everyone else isn't smart, but I feel like they just kind of understand a different realm of principles, which they do in a sense. So that's really cool. Typically, if there's any electrical shorts or electrical open connections, anything that's kind of funky that isn't necessarily tied to, like the body of the system or something, then the electrical engineers will be consulted for their advice. And typically they do a lot of root cause analysis as well, which we'll get into that when we talk about reliability engineering. But when it gets to PCBAs, sometimes the mechanical engineers that with that degree do not really understand what's going on, me included. So those are the electrical engineers. So between the electrical engineers and mechanical design engineers, those two are typically considered hardware engineering because it's like a physical thing. Now we get into software. So between software, there's also two kinds. There is flight software. So that's going to be more macro level software design. So it's kind of like, how will the system work? What are the kind of higher level commands and higher level happenings within the software to make the system work? Obviously, I'm not a software engineer. I know very, very, very little about software engineering. It is all gibberish to me. I don't even know Python. Let's just start there. But they're also very smart people. And what you'll run into is that a lot of failures are due to software. So it gets really tricky as a reliability engineer with little to no software background to deal with those types of failures. But yes, there is flight software engineers, and then there's firmware engineers, which these people are a different level of intelligent. So what exactly is the difference between firmware and software? So firmware will actually, so if you think about a PCBA, it's a circuit board assembly, right? That's like a system in itself. The software engineers typically just kind of use the functions of the chips that are on there to make the system do something. But the firmware engineers will design what that chip does. So it's kind of like making something from nothing almost, which is really crazy to me. That's as far as I know, if I'm being really honest. I know whenever I have some like software / electrical issue or some question, I typically just ask like one of the electrical engineers, and then they kind of lead me to whether I should go to like software or firmware. Just because like I never actually know the difference. But if you want to know more, do your own research because I'm not going to do it for you. But anyway, the final kind of type of designer / responsible engineer is going to be the more broad, like architecture type engineers. So between them, there's the architect, which they don't build houses. The architect designs they define the general kind of like use case of the system. It's like, oh, this thing is gonna behave this way and it's gonna work like this. And they just define kind of like how it's going to work. It's the architecture of the system. Then there's a system engineer. The systems engineer usually is in charge of defining the system requirements. And between architect and systems, honestly, I don't really know. It kind of gets muddy between the two. But I usually go to either one of them, and they usually have generally the same amount of knowledge and generally the same amount of knowledge about the system and like power over the system. So systems and architecture. So now we mentioned the designers and the REs of a production engineering environment. And the second group of engineers is going to be the production engineers because we do have to produce a product. So if you think about it, the designers are going to design the product, but there needs to be a way to actually make the product. And especially if you want to make multiple of the product. So that's when you get into the production type engineers. So the kind of first and foremost, most kind of straightforward is going to be the manufacturing engineers. They are typically in charge of designing how they're going to make the design. So it's kind of like, the main designers are going to make the product, but then the manufacturing engineers are going to design the way that they're going to make that product. There is more or less like their responsibilities are very broad. I've worked in two very different types of production environments. One is a high volume production environment, which heavily focuses on automation. So lots of robotics, lots of like station by station things, lots of programming that goes into it. In those types of environments, you're going to need automation engineers. So manufacturing automation are somewhat interchangeable for certain people that have those skills. So if a manufacturing engineer is really good at coding robotics, then they are also typically the automation engineer, and those are typically very golden people to have. But sometimes there are also automation engineers, which are very software based, and they are typically in charge of making sure the whole assembly line, which is usually automated, happens in a timely manner. Lots of discussion about yield, which is a very hot topic for high volume production environments. They're going to care a lot about like speed and optimization and how to time everything correctly. And all of that is going to be done through code. And so those are going to be the automation engineers. The manufacturing engineer will typically design the station. They will, if there's any kind of robot that doesn't already exist, then they will be in charge of actually making that robot. So kind of like one example is if you are trying to automate you're trying to box something up, right? At the end, after everything is made, you're trying to box it up so that it can be palleted and then sent to FedEx to be distributed. And you, at your current state, do not have a robot that automatically boxes it up. Then the manufacturing engineer will typically design the box maker. So that's kind of like what they do. They will also be in charge of kind of maintaining that station, optimizing that station, making sure that it's hitting rate that it's supposed to be. And if there's any maintenance to be needed, or if the station starts failing or anything, they're usually in charge of fixing it as well. So that is a manufacturing engineer and the automation engineer. And then there's more. Now we start to get into kind of the more support roles, but I'm still going to add these two into production. So one is production quality. So quality is a very important role within a production engineering environment. Sure, you can design a product, but typically the designers are going to create something that is perfect in their eyes and so easy to make perfect if you build one of them. But once you start making many of a certain thing, you start to have differences in the piece parts, differences in the way the robots are making these things, or if you're working in a production environment that is still very manual, which is actually the current case of my current company now, and people are putting it together, then the quality is also going to be extremely shaky because human error, right? Like people throw that term around, but this is like human error is very, very real in a production environment. So all of that kind of falls within quality. And yes, they are called quality engineers. They are still engineers. Sometimes it happens to be a lot of documentation, communication, project management, but you'll be surprised. You don't have to be extremely technical to be considered an engineer, which I do not consider myself to be an extremely technical person. I'm kind of forced to be somewhat technical in my role. But for me, as someone that is not very technical, reliability engineering, quality engineering, and anything in supply chain, which is actually the next one, do not tend to be super technical. If you can kind of get away with not remembering how to make a moment shear diagram. You know what I mean? But yeah, so there is production quality, and they will think about the manufacturing quality of things. And their role also bleeds into supply chain a little bit. So supply chain is a beast. It's a beast of a role and a sector within a company. So in a company, when you are making a certain product, especially at volume, you need parts to build at volume. Like you need parts to be in inventory so that you can go get that and make the thing that you're supposed to make. Who's in charge of getting the parts in inventory? That is going to be supply chain. And so there's going to be a couple different engineers here. There is the sourcing engineer. So supply chain is kind of a mix between engineers and non-engineers. There's going to be buyers, which are not considered engineers, and planners, which I think there's sometimes they just group certain roles into one title, but there are titles such as buyers, planners, so that you can kind of time everything and make sure things are coming in at a timely manner. And then when you get into engineering, there's sourcing engineers, which who are in charge of finding different suppliers to buy from, and choosing them based off of their quality, based off of their reputation, things like that. And price is going to be very, very important in a production environment. And then there is supplier quality engineering. So that's kind of where the bleeding between production quality engineers and supply chain happen, is between supplier quality engineering, or some places such as SpaceX will call it supplier development engineering. And these people will specifically focus on any quality issues that are coming at the piece part level. So if the supplier is sending over pretty shitty parts and batch to batch, certain measurements are kind of different and it's just causing a lot of issues downstream, then the supplier quality engineer will work with the suppliers directly to either help them develop their production lines, their production processes, and usually they're kind of the liaison between production and whatever issues are downstream, and then the supplier. So that's kind of the entirety of production. They definitely haul ass to get things done. Very, very impressive people. But yes, definitely needed in a production engineering environment. Now it gets into the section of engineering that I am in personally as a reliability engineer. And it is the support type engineers. So I didn't know exactly what to call this section of engineering, but I just call it support role because we just kind of support every team and every type of section of engineering. And there's kind of two that I could identify. There is reliability engineering, so that's where I fall in. And then there's test engineering, which I think it falls in the support role. But before I get into reliability engineering, I'm going to just talk about test engineering. Test engineering can be split up into electrical, system, and mechanical. So at SpaceX actually, my role was extremely test heavy because yes, there were test engineers, but those test engineers were typically focused on production. So, oh yeah, I should have mentioned production test engineers. There is test engineering within production, and usually they will be in charge of either writing the software to test the system to make sure that it works and everything checks out before it leaves the door, or they will be in charge of making any screens such as not actual screens, but when you're screening for something, when you're screening for any defects, screening for any faults and things like that. Usually the test engineers will be designing those. So yeah, add that to production. But the other side of test engineering is going to be design verification / validation testing, and like system level testing, kind of like production checkouts, system level testing, things like that. But for conversation's sake, I will keep it at design validation testing, and any reliability testing. So test engineers typically will do a lot of like execution in terms of engineering. So if there is this new part that we have never tried out before that someone designed and was like, hey, I designed this thing in my simulations. It looked fine, but honestly, I'm scared of A, B, and C. Can we please do some thermal testing to make sure that it doesn't fail a certain way? Then the test engineers will actually be like, yeah, sure. Like, we'll schedule it in. Usually they will have a lab that they run full of thermal chambers, vibe tables, and then any like instrons, which is, how do you describe an instron? Think of like hydraulic press, but also it pulls things apart. So like force-based and displacement-based kind of linear action. If you don't know what an instron is, please look it up. If you're curious, of course. And if there's any test that doesn't have some kind of rig already made up, then the test engineers will typically also design those test rigs and, make sure they work. So a lot of like fixture design, kind of just like test rig design, things like that. So that's kind of what test engineering does. And then in terms of software, they will also run some power tests, some kind of like fault injection. So like kind of putting in bugs in the software and see if it like actually catches it, and like how it reacts, things like that. And for electrical testing, they will, put a load on it, see how the circuit board reacts, if everything is like to spec, so on and so forth. Very, very broad. And I think this is like kind of the general theme of a support role, is that it's very broad, because they will deal with kind of like all facets of an engineering company. And test engineering will exist even outside of a production engineering environment. So it doesn't necessarily have to be like, a product that they make. They could definitely, there's a lot of test engineers in R&D fields, so like research labs, and like other startups that like don't make things yet. And literally just every other engineering field, I feel like test engineering does exist. So definitely, I don't know if test engineering is something specifically called out in college ever, but if you have any kind of engineering like education, you can get into some type of test engineering, especially if you have an EE background or a software background, and sometimes a mechanical background too. So there's test engineering. So now, the second support engineering that I have defined is the one I am in, which is reliability engineering. And okay, I'm not gonna lie, I think reliability engineering is like the most questionable one. Like as in if I say I'm a reliability engineer versus any other type of engineer, it's the one that's gonna be like, what do you do? Like, what is that, right? And I'll tell you what we do. At my current role, because it is a startup, I will say, I also question what I do. But I think it's one of those roles that can be flexed in many different directions. But between the two jobs that I have worked thus far, there are some similarities. There are definitely some differences. And that will just be the same, I think, for any engineering. If you like go to a different company, like roles are just slightly different by nature. But I'm just going to list out a couple things that I've done in each job that I've had, and maybe that can clear things up. So at SpaceX, My official title was hardware reliability engineer. I used to be called a BRE, which was build reliability engineer. Was it? Maybe. I think it was build reliability engineer, but that got kind of split, and we changed our title because it wasn't like build reliability is actually closer to production quality, whereas hardware reliability is more design validation and fleet level reliability analysis. So at SpaceX, one of my main kind of tasks was test, actually, because there was no hardware test team. That was us. That was the reliability engineers. And so that, I would say, was probably 80 to 90% of my role, which is like pretty heavy despite being a reliability engineer. So what did I exactly do? So at SpaceX, what we did at Starlink was a lot of test coordination. So for any new product in kind of the new product development cycle, after their design review and when they start like ordering their parts so that they can, start making prototypes, we are typically given a lot of whatever quantity they have so that we could start testing. Because testing is very, very important, especially if you are going to do something at high volumes. Making sure that you do high volume testing, of course, in a smart manner without like wasting too many resources, is going to be very, very important to make sure that you have correct failure predictions down the line. So we did a lot of test coordination. Whenever there was a new product, we would be in charge of defining and executing the qualification campaign. So there was a lot of campaign this, campaign that at SpaceX, and qualification / reliability campaign. So we always called it a reliability campaign, but honestly, it was more of a high volume design validation campaign. So just putting it through accelerated life testing to meet the specifications of our product, going through vibe testing and just putting it through all these different types of environments that a customer would typically see and would typically stress it with. And we're not just talking about like LA, right? We're talking about really, really hot places like Africa, or really, really cold places like Alaska or the Antarctic, Russia, I don't know. And it's like weather, but also how much UV, it's getting. Let's see, what else? If people are using it in the dirt, like is dirt getting into the thing going to be a problem? And just like kind of defining all these kind of high risk cases and ranking it from like most critical / gonna happen the most to like this is a really extreme corner case, like don't even test it. And just kind of like defining and kind of identifying. There's a lot of proactive exercises that a reliability engineer will do to make sure that we are not wasting time during product development cycle, like in early development, and kind of working with the design engineers to identify the risks depending on what the design is, and then just try to mitigate it from the get-go. So we'll do a lot of test coordination. Along with that, if we are producing the product and then the design engineer, or because of some like failure that happened, they decide, we're actually going to change this part. But we don't know if like changing the part for X reason is going to cause it to fail for another reason. Then what we typically did as well was a change qualification campaign. So we would be in charge of like drafting up a test plan and then executing that with our lab team. And then I mentioned failure analysis, root cause. If there is any failure, so any failure in test, any failure in the field, so field, we will call it field, when the product is with the customer into the wild, one might say, it is the field. We call that the field. Our customer base is the field or the fleet. These are very like aerospace terms, but we also call it fleet, which is kind of a fun term. I like using fleet. If there's any failures out there or in test, then the reliability engineer at SpaceX, when I was at SpaceX, we would also be in charge of leading root cause investigation, so finding out why it failed, and then kind of closing that loop up with corrective actions. So if we root cause it to, hey, like this joint does not have a large enough radius, and that's why it cracked, then we would feed that information back to the design engineer and be like, hey, you need to change this, and then they'll change it, and then usually they'll change it, order parts, and then we have to qualify it again. So a lot of testing and a lot of firefighting. I know if you are a reliability engineer or some kind of like failure analysis / root cause engineer, there's going to be a lot of firefighting is like a very popular term. So typically acting very fast, trying to get the root cause extremely fast, and it's kind of the most rewarding and the most stressful part of the job, I will say. And I'll get into that a little later when I go over like the pros and cons of reliability engineering. But definitely that's like probably the other 20%. 20 to maybe like 40% of the job is like failure analysis and like root cause. And then let's see. What else did I do at SpaceX? I feel like that's honestly a lot of it. I'll also talk about this later, but it's also a lot of project management. So like I said, we are coordinating test campaigns. We are coordinating root cause investigations and things like that. But when you are testing like a product or a piece part, there's a lot of people that are interested in what you are doing. And so trying to, get the parts to test, then putting it into test, getting the software you need to run during the test. Like you need to coordinate all of these things with different people so that you have the resources to actually have a meaningful test, so that you have meaningful results that the REs or whoever can use. So it's a lot of project management as well, which I think a lot of people actually would not like to do. But as someone that enjoys kind of being a group leader or like being a project leader, in my opinion, that's kind of like one of my favorite parts of the jobs. So now jumping into my current job, I'm not mentioning the name because I don't know, I feel weird about it, but it is a defense job at the end of the day. There are some similarities. So root cause, corrective action, failure analysis, that I still am a part of. I will say, I think reliability engineering in my current company is a very new concept. And so people are not quite used to going to us first with problems. And so I've found that a lot of the times I'm left out of the conversation, which makes like absolutely no sense because like I actually should be owning the investigation. But I think going forward, I'm just hoping that changes. And it does look like starting maybe a couple weeks ago, that is somewhat starting to change. And people are starting to come to me to like actually lead investigations, like follow up on things and like run testing. They are coming to me for those types of questions now, which is, I think, better. Of course, my scope then increases, but it was my job to begin with, so I'm not complaining. There is reliability and qual test level definition. So I think the main kind of difference between SpaceX and the current job that I have now is that whereas we were in charge of test coordination and defining the test at SpaceX, at my current job, we define the test and like how, like the level of like, what do you call it? The aggressiveness of the test and like what temperatures we should run things at, things like that. We define that at my current job, but we are not in charge of test coordination. There's a completely different team for that runs the test lab. And so we have to work with that team to do test coordination. But in some ways, it's actually kind of nice because I don't have to worry about scheduling and dealing with technicians, which was both like really nice and stressful at the same time at my previous job. But yeah, so I do a lot of like requirements definition, but not necessarily coordination and execution on the test side of things. And then I talked about requirements definition. So as a reliability engineer, I am also in charge of defining the reliability requirements of the system. So what does that even mean, right? So when you talk about reliability, there's kind of like two different ways of actually thinking about it. One is reliability of the system at T0. T0 is going to be time zero. So how many infant failures are we having in the field? Like, are things failing immediately and for a really dumb reason that we just like didn't catch? Or is it failing 5 years down the line? Like, how long does it last? All these questions are very reliability-based questions, and kind of quality. But how long does it last is a very reliability-specific question. And obviously we don't want a lot of early failures, but we also want to make sure that we are hitting a certain lifespan of the product. And so we are in charge of actually defining those lifespan type requirements. So it's supposed to last 5 years in the field, or it's supposed to last 500 hours of flight. It's supposed to last X amount of cycles of load, things like that. We are all supposed to define those. I say supposed to. I haven't done any of it yet, but I know it's within my scope. So we do that. We define risks. So at my current job, what is actually, I believe, different from other reliability roles is that it's extremely proactive based. So there's a lot of emphasis on proactivity. And what that means is there's a lot of firefighting when it comes to reliability engineering, so fixing problems that have already happened. But with more emphasis on proactivity, you can honestly prevent a lot of the firefighting that happens. So proactivity is obviously going to be more resource heavy. It's going to take more time because it's going to take a lot more predictions and things like that, and a lot more kind of thinking, like critical thinking, a lot of mitigation testing, but kind of down the line, it's going to be a lot more beneficial for the design. And I think where that emphasis lies between firefighting versus proactivity is going to be a decision based off of like more upper management, depending on kind of the goal of the market. So for us currently, reputation of our product and reliability of our product is very, very important to keep the cash flow moving to us. So if our product is failing super often in the field, we're not going to get more contracts down the line because like these people are going to hear about it and they're going to be like, no, we don't want that. Like we heard that your thing falls out of the sky and crashes like half the time. So a lot of proactive measures are extremely important for my current role. At Starlink, it is also very important, but I, for some reason, did not get the feeling that proactivity was like a huge emphasis. Well, it should be. I feel like it should be for any like company, but anywho, I did not get that at SpaceX. But here at my current role, proactivity is very, very heavily emphasized. And how exactly is that exercised? So there will be risk mitigation testing. So I said we don't do a lot of test coordination, but honestly, I feel like when you're in reliability, you kind of dip your fingers into everything. So you do take part in risk mitigation testing and coordination and defining those tests, things like that. But then you also, there's a lot bigger emphasis in FMEAs. So whenever you're actually interviewing for a reliability engineering role, especially hardware based, you're going to be asked to kind of do a impromptu FMEA. And what the hell is that? What is that acronym? It is failure modes and effects analysis. Basically, if you have some kind of system, you create this like master Excel sheet. It is typically an Excel sheet, I'm not lying, that lists every single piece part that the system is made out of. And then you start listing all the different types of failures that can happen, just depending on the material it's made, how it's used, what conditions it's going to go through, what the geometries are like, and you just like list them all out, and then you list the effects. Like what kind of effect is that going to have? And then you can add like the criticality factor in there, which is something that is required for a defense company. But criticality is kind of just like more of a, like, how serious is this? Is it critical? Like, is it a safety thing? Or is it, minor? And it's just kind of like a user experience thing. Like it's a minor inconvenience. So defining that is also part of the FMECA. And it's kind of just the analysis of what you think is going to be what might happen in terms of failures. So there's really heavy emphasis on identifying those risks. And within the FMEA, there's also like functional hazard risk. There is safety risk analysis. All of these are kind of the same thing, in my opinion, just different flavors of an FMEA. So very, very heavy analysis, like emphasis on that. And then there is also a lot of metrics. So I know at SpaceX, we actually had data science roles that more kind of emphasize on the metrics of everything. But at my current job, the metrics is actually something that we do as reliability engineering. So I've actually gotten really good at data analysis, or at least data manipulation, which is a skill that I've always wanted to have, and it's really nice that I have it now. In the like 3 months that I worked there, so very fast learning. But in terms of metrics, it's more of a tool / visualization method of being able to see kind of where you lie in terms of reliability. So a very, very typical metric is kind of like failure rate. That is a metric. And how do you typically kind of visualize that? What we'll do is there's going to be tons of data out there. And that's kind of based on like the data engineers or whoever's in the back end to kind of populate those fields. But the reliability engineer or whoever's actually using those metrics will use those data points. And reliability engineering for failure rate will use typically like how long was it in the field until it failed? And then we'll use those type of things to generate a MTBF or MTTF, which are very common reliability engineering terms. So MTBF, mean time between failures, mean time to failure, which are very important numbers to generate to then drive a risk or a failure prediction. So it's kind of like, how long will it take? Like, in the next 10 years, how many are going to fail? In the next 5 years, how many are going to fail? Like, these are questions that a lot of engineers within the company are going to ask you as a reliability engineer. And how do you actually generate those numbers without everything actually failing, right? You have to do a prediction. And how do you get those predictions? On data that already exists. And so you can use failure data that has already come back from the field, or you can use data from testing. So yeah, that kind of ties in all of reliability engineering. So next I'm going to get into the pros and cons of my role. So let's start with the cons, because I always like to end with a positive note. So the cons. When you're in reliability engineering and you deal with the failures that come from tests and that come from field, and you also deal with a lot of risk mitigation, a lot of risk identification. Whoa, I totally butchered that. You start to become a devil's advocate. And this makes your job very tough because it is very much you against everybody else. And what I mean by that is you are the person that are putting like the stop signs down on the road when everybody is just trying to race down the road. And you're being like, no, please stop. The design is bad. We have proved it. We are seeing this failure. We need to fix it before you can proceed. And people really, really do not like that in a production environment. What you'll typically get at a production facility is all efforts will be made to meet a certain schedule defined by who? I don't freaking know. There's a lot of manufactured urgency with these companies. Deadlines are, in my opinion, fake all the time. What are they driven by? I have no clue. I really don't. Someone up there said it needs to be done by next year, and that's what everyone is working towards. And so manufacturing, designers, supply chain, all these people are trying to go as fast as possible. Reliability engineering, you're going to have to be devil's advocate. You're going to be the one slowing things down. You're going to be the one that everybody hates because you are blocking the road and they want to just race down the road. And so that does get a little stressful because when you're so passionate about something and when you're so like involved and spend all your work hours kind of working for something, honestly, I feel like people start to take work very personally. And at SpaceX, I mean, you've heard the rumors. People work their crazy hours. It's a lifestyle. And of course, people are going to take it personally. And so, have I, gotten sour relationships from being in my role? Me personally, I don't think so. But I've definitely seen some people that had like soured relationships just because of work, which is crazy because otherwise they would have been great friends. But obviously it's kind of it's a game. You want to be the devil's advocate very tastefully, and with reason. You can't just call the stoppers because you feel that something is kind of off. Obviously if you see something, say something, but a lot of the times, you will be asked for proof, you'll be asked for testing, numbers, pictures, things like that, before you're actually able to kind of put the stoppers. And it is in the end, you should do it tastefully and you should really only call stoppers if it's actually that urgent. So yeah, there's sort of an anxiety that is tied to being devil's advocate all the time. Speaking of anxiety, the biggest con, I think, of reliability engineering, especially being so involved with failures, is you start to get scared of failures. Because if there's a failure, like sure, the designers also really stress about that because they have to, in the end, like do a lot of work. But you, as a reliability engineer, are pressured to find what exactly went wrong. How do we fix it? Who do I talk to like investigate this together? And there's a lot of communications that you have to do, a lot of things you have to coordinate, a lot of conversations to be had, to get the root cause done extremely fast, as possible, of course, based on this like fabricated urgency. And just kind of get things all in order and coordinate things. Basically what I'm saying is whenever there's a failure, there's a lot of work that you have to do that is tied to a certain failure, to make sure that it doesn't happen again, to make sure that we fix whatever was the problem, and to make sure that whatever this issue was, that it's correctly defined so that it's not in, later on, like a safety hazard or something. So there's a lot of anxieties kind of tied to any failures, even though that's part of my job. And that's like the hardest part of it all, right? Like if there's a failure, typically people just want to avoid it altogether. They just don't want to think about it. They want to push it off to the next person. But that next person is us. We are in the end in charge of actually dealing with those failures and like at least delegating it to the right people that can answer the question and can find the root cause. So there's a lot of anxieties tied to that. The next thing is there's a lot of documentation, and that's fine. So documentation, I don't mind too much. Of course, there is always so much documentation debt that needs to be had because, again, all these people are trying to move extremely fast and they don't document things like 90% of the time. But that's kind of like, that gets into the main reason of why this is a con, is not just that you have a lot of documentation, it's that other people suck at documentation. Like so with any company, there is always a chatting / messenger program, like application, right? At SpaceX, it was Teams. At my current company, it's Slack. And, messaging applications typically are not considered actual documentation, but what people will do is consider it actual documentation. They think, oh, if I say something about it in this messenger app, I did my due diligence in documenting what I did. So they'll literally give like test reports in Slack, which is mind-boggling because it gets drowned out so extremely fast. And at least in my current company, I don't know if this is true for any other company, just so that we save like data, messages get deleted after 30 days. So if you gave your test report in this like timed messenger application and that goes away, there's no documentation. Documentation never existed. You never did the test. So dealing with that and making sure that everything is translated into something more permanent is honestly, I think, the most annoying part of the documentation aspect of my role. Like, why can't you just make a JIRA ticket? Like, why can't you just put it on a Confluence page? Just throw it on there. And so I've gotten extremely good at Atlassian applications, which, oh my God, I love you, Atlassian. Atlassian? Anyways, Confluence and JIRA, slay. So slay. I love those two things. And some people will say like, oh my God, I hate JIRA. But that's because you're using it wrong. And you fill out tickets terribly. And that's why you can't query for anything. I said what I said. The last part of this is going to be a lot of doubt in your own work. And I know this sounds scary, but I think it truly does come with the nature of kind of what we do. So when it comes to risk or like failure predictions, these are predictions, right? Predictions is just a fancy word for educated guess. It's a guess. And when you're putting numbers to a prediction, sometimes these numbers are really phony. And when you're, especially in a startup environment, which I am now, test resources are really, really hard to come by. And I don't mean like thermal chambers. I'm talking like sample sizes. Our sample sizes are one or two at best. Getting a failure prediction off of 2 samples does not work. Like, these are totally phony numbers. And there's going to be a lot of made up numbers when it comes to even like test profiles. So this might get a little too not technical, but maybe a little too niche. But when you are making a thermal profile, you want to do accelerated life testing, because if you want to see if something lasts a year, you're not going to test it for a year. Unless you're in some really early startup that like is not planning on releasing anything anytime soon, you don't have a year to test. And so you need to manipulate your test profile so that it's shorter than the actual duration that it's supposed to be equivalent of. And so that's when you get into the science of accelerated life testing. But when you do that, you have to do a lot of testing beforehand. Like it's very like cyclic, like a chicken and the egg kind of logic here. But you need data of a certain failure point or a certain failure material to actually generate the correct numbers to create that profile. So, for example, I think this one's like a very common failure point that people will use, but a solder joint within a PCBA. So solder is, think of it as like the metallic glue to glue the components onto the board. But solder joints are typically quite weak, especially when it comes to like cyclic loads. So cyclic loads meaning thermal cycling or vibrational loads. And that specific failure mode, you need to generate somewhat of an SN curve. If you're not an engineer, you will not understand much of this, but you need to generate an SN curve of kind of like loads to stress, like cycles to stress. I think that I know what an SN curve is, and then get the slope of that to actually generate the material exponent. So it's like this number. I think it's the actual slope of it. I'm not too sure. I haven't done this in a while, but you get that number, and that number is what you need to actually generate the thermal or whatever acceleration profile for what you are trying to test. So you see how like how much time that takes? Like, you need the actual test data of the material to then feed back into your thermal profile to then be like, hey, if we test for 3 cycles, that actually means 10 cycles in the field. And 10 cycles is equivalent to 30 days because these XYZ assumptions. And see, there's so many assumptions. And when you're working in a very fast-paced engineering environment, especially production environment, you don't have time to do the testing to generate that SN curve to then feed back into your thermal profile. And now you start doing some guessing, a lot of Googling to then be like, oh, we use solder. We can just use past data from what people have done in a more research environment who had the time to actually develop these SN curves. And just use those numbers because they already exist, right? Like we don't have to do the testing. Fun fact, solder comes in many different forms and in many different material makeups, and they all have different material fatigue exponents. So it doesn't actually always quite work out like that. And people do not like to address that fact, and they'll just use whatever numbers online for a lot of things. Of course, if it's like a very specific, critical joint, very high kind of effect / consequence, then they'll probably schedule in the time to do all that testing. But I feel, for consumer tech where things are made in the thousands, sometimes they're like, a guess is good enough. And so that creates a lot of doubt in your own work and a lot of anxiety in terms of actually justifying a certain profile that you've made up. And I will say, even though these are all guesses, usually the math will be in the ballpark of what it actually is. So, or we will intentionally use the more conservative numbers just so that we're over-testing rather than under-testing, which there's consequences to that. But anywho, so don't worry about that. And like I said, for more like critical / safety related things, of course, they will do their due diligence to like do the testing. So don't worry. But when it comes to like defending your own work, it just gets a little more difficult when you know that you're using somewhat phony numbers. And so there's just a lot of doubt. And so I think that's also like definitely a con in my work. Now I'm going to talk about the pros of reliability engineering. And I will say, I've been in reliability engineering now for 2 internships, which equates to about 6 months. And then 2 years full-time at SpaceX, and then 3-ish months at my current job. So in total, like 3 years. 3 years of full-time experience. And I don't mind staying in this role. I know a lot of people that do start out in engineering did not intend to start in reliability engineering, and they usually intend to start in kind of the more shiny, like design roles. But me, I'm just kind of like, I just want to do good at my job. and earn a lot of money. And reliability engineering, honestly, I think fits my personality, especially as someone that likes to be project lead, like I mentioned, and just likes to coordinate things and like control things. It's kind of like playing chess, right? Like playing little pawns. And that's kind of like what I like. And that's like the first pro that I'm going to mention is that it's very good project management experience. And I'm not sure if you can use that experience to then go apply for like project management necessarily, but it does create really good leaders, especially within the reliability engineering role. And you just get to become really good at making decisions and just being like decisive about how things are going to be run. And so you tend to be a very relied on person within any program that you're on. So I do like that. I do like becoming somewhat of a owner in a lot of cases of certain efforts, and become like project management of a lot of efforts too, such as like test campaigns. That said, I think the other really good side about this is that even though you get really good project management experience, you're also extremely hands-on with the technical side of things. So when you're doing failure investigations and when you're doing kind of like test coordination and things like that, I've dealt with a lot of hardware like in my hands physically, and whenever there's a failure, I will be the one taking things apart and just like looking at what failed, trying things out again, like tinkering with certain things and just like prodding, and you get to learn a lot that way, I will say. Lots of learning opportunities. That's like a huge part of the pros, is that you get to learn so much and learn like every bit of a lot of things. I will say, I think the con that I didn't mention is that you don't become particularly an expert of anything, because you're just kind of like bits and pieces kind of gathering information. But that's also a pro, because you don't just learn about mechanicals. You learn about test engineering, you learn about software, you learn about manufacturing, you learn about electrical design and things like that throughout your investigations and your test efforts. And so you get to talk to a lot of people, make a lot of friends. I just feel like it's a very open role, and you just have a lot of opportunity to learn. And so that's definitely a huge pro. And I think the second to last thing is you get to learn a lot of useful skills that I think really benefit the company as a whole. So I'm just going to mention one thing, but a lot of like what I do, so I mentioned earlier, is metrics. And with metrics and data manipulation, I've learned a lot about SQL and visualization tools such as Grafana or Palantir's Foundry. And being good at these things is weirdly powerful. Like, I've had design engineers come up to me and be like, hey, can you just like manipulate this data to kind of tell a certain story or like kind of reveal a certain trend? And at first I was like, I don't know anything about SQL. I don't even know where to begin. But once you kind of get into the groove of things and you know exactly like what your end product, like you want your end product to look like, product meaning like the visualization, then you start to become kind of powerful, because you're like, wow, I can like see when things fail. I can see like, oh, this type of thing is running hotter than this version. And it's just like a very interesting skill to have. And it's very important for any kind of engineering that you're in. Like data is everything, in my opinion. And I think it's so sad, because a lot of companies and a lot of upper management do not realize this, is that data is absolutely everything. Like, if you want to have a really robust company and have, continuous improvement, you need to have good data integrity so that you can use that data to tell a story to then feed back to design or whatever. And being a key proponent of like telling that story and using the data and like driving for better data integrity is like a very powerful position to have. And so I really like that aspect of my current job. I didn't do that so much of that in at SpaceX, but in my current job, I do a lot of data integrity effort. And so that's been like kind of one of the more like fun aspects of my current job. And then the last thing that I'm going to mention for the day, I know this is going to be a long one, but I think this point actually is going to be very attractive maybe to newer engineers, is that it's very easy to learn on the job. And if anything, it is a job that you have to learn on the job. So like I said, it's not very, like, it doesn't necessarily have to be so technical. You do not have to be a technical expert to be good at this job, because I'll tell you now, I'm not a great engineer by trade, as in like my technical skills definitely lack. But you pick up a lot of technical skills on the job anyway, no matter what engineer you are, because school only teaches you the very basics. And very like theoretical as well. So a lot of more hands-on, more kind of practical skills you will learn on the job anyways. But as a reliability engineer, you're not typically taught reliability engineering unless you have like some really fancy school. At least in UCLA, that was not, I had no idea what a reliability engineer was. Like going into my first internship as a reliability engineering intern, I was like, what the frick is this? Like reliability? Just make it better, like just do better, I guess. But there's like obviously so much more to that, right? Like it's a support role. It's supposed to get the data, feed it back. A lot of communication, like it's filling the gaps of that feedback loop that wouldn't exist without like reliability or any of these like support roles. Like I said, it's very easy and almost necessary to learn on the job. And I will say, my interview experiences at both jobs have been weirdly, I don't want to say easy. So, okay, there's a little bit of a disclaimer here, but when I joined SpaceX, I came in through a return offer from my internship, which is the best way to get in, because I know typically SpaceX interviews are actually quite difficult and very technical. But for me, luckily, I don't think this will happen to anybody else, but I did one phone interview with a senior engineer, and it was all behavioral questions. It was all questions that you like ask ChatGPT, what are some typical behavioral questions for an engineer? Like that list is exactly like what she did, which maybe is a testament to how ready she was for that interview. But I don't know what she saw in my answers. I can't even begin to tell you. But immediately after that, I got the offer for the internship. Maybe they were just that desperate. I have no idea. But that is the only interview that I've ever done at SpaceX, was one behavioral 30-minute phone call, which I think I just got very, very, very lucky. And thankfully, I think I busted my ass at my time there. And so I was able to get a return offer for a full-time position. And I worked with them for 2 years. And I still love that team to this day. And I think of them as like my family. I'm not gonna assume that you're gonna have the same interview experience as that, but I'll leave it at that for SpaceX, because I actually don't know what else, like how else the interview process would be. I just know it's difficult and very technical, and you need to do a presentation. So there's that. For my current company, I had one interview with the principal engineer. Well, it was like a phone screening, which is not even an interview. They just like check if you know basic shit. And then I had one interview with a principal engineer. She just kind of asked me about like my experience. And then I had a panel interview. They say panel, but it was just like 5 one-on-ones back to back. No presentation. All of them asked basically the same questions, which was just like about my experience and like, do I know certain things? Do I not know certain things? Tell me about a investigation you did, etc. Things that I feel like if you have even a year of experience, you should definitely have in your head, like the back of your hand. That makes no sense. And then my last one was another Zoom interview with kind of like the executive director, which he was supposed to interview me on the onsite, but then he couldn't make it. So then that's why he did it. But he mostly asked me about more like team development questions. So like, is there anything at your previous job that you think really worked in terms of like team dynamic that you would like to bring over here? Very general questions. I think, especially because it was a startup environment, they are still developing their team, and so they wanted more inputs in like how to actually do that. But overall, the only thing that I really needed to prepare for these interviews, for my current job, was like my resume, which you should do that for any engineering job. Is like you should know your resume with like as much technical depth as possible, and you should always present your resume as if like you did everything by yourself, and then you should just know every detail in depth. And as long as you do that, I feel like reliability engineering, you could pretty much secure any reliability engineering job. But again, I don't want to speak for every company out there, but typically that's what I've experienced. I also did an interview with Apple. I did get rejected, but in retrospect, I think that was kind of a good thing because I wasn't getting very good vibes from that team. But yeah, I think the interviews tend to be a little less technical, because it is a less technical role by design. And it's more about like involvement, communication styles, investigation, leadership, and like driving actions. Like that's like a big theme of these like questions that they ask. And it's not so much about like, do you know what the stress strain curve is for this material? It's not like that. Again, like if you're nervous about like, oh, am I supposed to have experience with reliability engineering as like a student? No. That is not expected out of you. Never. I think a lot of these like support roles, such as like supply chain, production quality, reliability, typically you do not need to have like internship experience with those things. That's kind of it. I hope that this was pretty eye-opening for engineers out there that do not work in a production environment, or I guess like for engineering students, or I guess if you're just not in engineering in general and you just wanted to learn about the different types of engineers in a certain kind of company, like what they do. So yeah, I hope it was pretty eye-opening or at least informative. I'm going to end it there. This is kind of a long one, but I hope everyone has an amazing Thanksgiving. I hope you join me for the next one. Bye, guys.